What is chemistry? Chemistry is a set of practices that humans do to develop knowledge about the matter that makes up our universe, the properties of different types of matter, how they function, how they interact with each other, and how they combine and recombine. So what is matter? Matter is stuff. It's things, objects. Anything and everything that you can touch or taste or smell or hear or see is matter. And in fact, the matter that your senses can interact with make up only a tiny fraction of the matter in our universe. Leaving aside dark matter, an unknown material that has mass but doesn't interact or maybe only weakly interacts with light and other matter, 3/4 of the visible matter in the universe is in an interstellar gas so diffuse that we didn't even have the technology to see it until this year. And that picture of the Earth at the top, the heavy elements that represent 0.03% of the cosmos, that's us. That's all the elements apart from hydrogen and helium. It's kind of amazing to think that everything you've ever touched and everyone you've ever known all exist inside that tiny fraction of our universe. We classify matter in several ways. For instance, we can ask if every sample we could take of a particular amount of matter is the same. It's like a smooth, homogeneous vanilla ice cream, or if parts of it are different from other parts, like a heterogeneous salted caramel ice cream from Reed's Dairy. So in here we can see that the caramel ripples are obviously different from the smooth vanilla ice cream parts. Each one of those two phases is different from each other in properties and characteristics, but they're homogeneous inside of themselves. So next we can ask if the homogeneous matter can be separated into different phases by some physical process, like melting or distillation. So for example, we could melt the ice cream, set that into like a centrifuge to separate out the milk solids and the fats from the aqueous watery phase that's contained inside of that vanilla ice cream. And even inside that watery phase, we would have dissolved sugars, flavorings like vanillin, and the sea salt that give the ice cream its flavor. Because we can do that, we know that the ice cream, even though it's homogeneous, is still a mixture of these different substances, or it's a mixture of these different ingredients. If we were then to extract only the sea salt, for example, that we would call a pure substance. Okay, if we were to separate out just the sea salt from our mixture, we find that in this salt there's only sodium chloride and nothing but sodium chloride. That combination of two different types of atoms is a compound. The only way that we can break apart that compound is by doing some chemical process. In this case, maybe electrolysis, where we pass an electrical current through the material to break it down into its separate elements. Those are atoms that are the smallest amount of stuff that is still that thing. We can still break down the atoms further, but at least for now, all we're doing is separating it into the sodium, a violently reactive metal, and a chlorine, a toxic gas. But I think we'll leave it at the compound where it tastes nice and doesn't try to kill us. To break down either of those atoms even further, we'll just apply more energy. We can either give it an extra electron or take one away, creating an ion, or we can do some nuclear chemistry to transmute it into an entirely different element. In our introductory chemistry class, you'll learn and apply the methods that we use to gain knowledge about all of these classifications of matter: heterogeneous and homogeneous mixtures, pure substances, molecular compounds, atoms, and even subatomic particles. Now, you might have thought that we would only talk about subatomic particles in a physics class, but actually the practice of chemistry has to include investigations of how electrons, protons, radioactive particles, and photons interact with matter to produce changes. After all, we can't talk about ion stability or chemical bonding without quantum mechanics. Nor can we answer questions like, why is gold yellow? And why is mercury a liquid? Unless we understand general and special relativity. Every science and engineering specialty is an approach to answering a particular type of question or to solving a particular type of problem. Each uses their own methods and tools to answer particular types of questions, but either because of the environment or the samples they're working with, or the instruments and the tools themselves, at the end of the day, their subject matter is matter, and chemistry is at the heart of all of these other sciences. So with that, welcome to the central science. Welcome to chemistry.